Aloka ma'am, good morning.
Good morning, Dr. Satya.
So
I hope I'm audible.
I think we can start, or we'll wait for another 2-3 minutes. Students are joining. Student will join also later. I think exactly at 10 o'clock we'll start.
Okay, sure.
Okay, fine. Anushka, are you ready?
Yes, sir.
Okay, fine. So exactly at 10 o'clock, after 1 minute, we'll start. Okay.
Okay, sir.
Ketan and Ankit ask participant to join. Session is supposed to be start at 10 o'clock. Just remind them once in WhatsApp group. So how was your Christmas, Aloka ma'am?
Yes, Doctor, it was good. Yeah, still it's the
Still
season.
going on, na? The Christmas week is going on. So I know you are
Yeah, still
busy
going
from
on.
your busy schedule. Okay, you and some time for our students. Okay, thank
Yes,
you.
of course. I can
Okay,
do.
Ankisha, now you can start. Ankisha, you just introduce ma'am and start.
Yes, sir.
Okay, thank you very much.
Aloka ma'am, just wait. Ankisha will introduce you, then we'll start. Yeah, 1 minute.
Okay, sure.
Welcoming Miss Aloka Fernando, ma'am, a research engineer at University of Moratuwa, Sri Lanka. With a passion of advanced knowledge, she is actively involved in research endeavors that contribute to our understanding. She has the privilege of sharing her insights and expertise with students, fostering a dynamic learning environment. Let's explore the realms of knowledge together with her. Over to you, ma'am.
Okay, thank you, Anushka, for the lovely introduction.
Welcome, ma'am.
Ma'am, you can share your screen.
Yes, of course. Okay. So, good morning to all of you, and a warm welcome to all the participants. I think it's a massive number, so it's overwhelming, and I like the enthusiasm you have over there. So, as it was correctly introduced, I'm Aloka Fernando from the Department of Computer Science and Engineering at the University of Moratuwa. Currently, I'm a final year PhD candidate. So, I have a BSc honors degree in engineering, and then I was in the industry for 8 years, and then in the academia, and now I'm completing my PhD. So the topic I have chosen for this workshop is sequence modeling and its applications. So let's see what is sequence modeling and how we can really apply it. So this is the agenda. So when we talk about sequences, I'm going to focus on the specific sequence data type, which is natural language text. So we are going to focus on textual data. So let me give you an overview on that. And then let's see what are the challenges in NLP, the journey so far, basically the landmarks which were vital for the improvement of NLP, and next we will see the neural network architectures that were actually supporting the progression of NLP, and then we'll take a look at two terms, NLU tasks and NLG. So let's try to learn what it is when we go along. And next we will move on to language representations, and then we'll do a practical, I'm sorry, let's do a practical session on multi-class classification. So I'm sure all of you would have heard the term NLP. which stands for natural language processing. So that's basically NLP is the ability for machines, or basically we are focusing on computers to read, write, to read, understand, and to generate human language, or what we call as natural language, as it is in spoken or in written terms. So this NLP is also subfield of artificial intelligence, because we expect the computers to make decisions on the language understanding or the language generative part by its own, without really having to program it. And then it also is overlap between machine learning and deep learning fields as well, because machine learning and deep learning models we will use to do this particular task, that is to understand the text or to read the text or to generate the text. So why is NLP challenging? Why is it a very uh, uh, popular research domain? So one of the key factors is the ambiguity in the natural language. So the same thing can be used, told by two people in different ways. Or although it is structurally not good, or even if the person is not really fluent in the language, still another person can understand it. But when it comes to NLP models, it is much more challenging. So why is that? So we have actually different types of ambiguities. Ambiguity is the uncertainty that a machine can have when it's trying to process the text. So we talk about lexical ambiguity. So when the lexical ambiguity means when a particular word can behave as an adjective, noun, or a verb. So in this particular case, or else it can have multiple meanings as well. So in this particular case, the rabbi married my sister. So it can mean rabbi actually perform the ritual of marriage, perform the marriage with the sister and the husband, or else the rabbi actually got himself married to the sister. So there are two meanings. Now this is much more challenging for the computer. And then what is syntax? Syntax is actually the structure of a sentence. So we know that the sentence to be syntactically correct or grammatically correct, it should follow the agreement between the verb, object, subject, object, verb agreement, or else the plural agreement likewise. But here, depending on how the sentence is formed, now this has a ambiguity. That is, the old men and women stayed at home. So here, if you can see, now it is uncertain to which noun this all belongs to. One can interpret that all belongs to men only, or else another can interpret that all belongs to both men and women. So here there's structural ambiguity. So when it comes to NLP tasks, the models should actually identify now what to do in this kind of a situation. And next type of ambiguity we call as semantic ambiguity. So here the meaning that is given out by the sentence is different to its literal meaning. For example, miners refuse to work after death. Of course, miners after they die, they cannot work at all. But this is a newspaper headline. So this was actually supposed to convey that some mishap has happened in that mining location, and then the rest of the workers were reluctant to work. So as you can see, these are some, this is one depth that a particular problem can go when it comes to NLP. Or else, the particular text can have colloquialism and slang. So these words cannot be found in dictionaries. They might be different from region to region, country to country. We don't know. But so with these things in place, still these NLP applications should decide correctly. Or else, when it comes to language complexity, some languages become complex owing to the morphological richness. Because whenever it's morphologically rich, it introduces words by inflecting based on the number, the gender, etc. For example, languages like Sinhala, Tamil, which are official languages in Sri Lanka, and also Amharic, which is a second language in Ethiopia. And this is not the only three languages. There are many, many more. And when it comes to certain domain specificity, now we have seen that certain certain models, NLP models, which had performed very well in certain specific domains, don't actually perform well when it comes to legal, health, or any other domain. So there are challenges when it comes to different domains. And another challenge is when it comes to low resources or very low resources, they lack the support for linguistic resources such as even dictionaries, glossaries, or label datasets, and certain linguistic processing tools such as postagers, such as grammatical parsers, right? So these are lacking. So as a result, the entire application performance will also degrade. And when it comes to speech processing, right? So there can be mispronunciation, different accents, stuttering, so etc. So then to correctly identify what the person has spoken, has to overcome these particular challenge. So as you can, this is just for just an eye opener for you to understand what is the complexity of NLP. So I'll just run through the history. These are basically milestones, important milestones in the history of NLP. So we can say that the NLP research began early as 1940s, and in 1950, it is considered as a landmark because the University of Georgetown and IBM experimented a translation system. Basically, it could translate automatically 60 Russian sentences into English. So this was the first publicly demonstrated NLP application. And then in 1957, Noam Chomsky, who is a linguist and also a professor, he actually introduced structured language or structured grammar, which was also supporting to model the language in terms of rules. And then in 1960, Minsky basically they decided. So this AI community, which was working as a group, right? So they actually started working in their specific domains or better controlled environments, because the complexity was much more the complexity of the language was much more like difficult when it comes to generalization. And then nowadays chatbots are popular, very popular, even in mobile phones. We have these applications. But the first sort of chatbot was ELISA. It was introduced in 1966, and it was supposed to be it was not coined as a chatbot at that time, but it was supposed to engage in conversation with imitating a therapist. So the human realized human could not actually understand that whether the response was coming from a system or from a person. And in 1970s, the knowledge representation happened. So this was the beginning of knowledge representation, where the real world knowledge information were represented in terms of ontologies, which was uh, moving onto a structured knowledge base. And moving on to 1980. So that was significant because it was supposed, during that time, researchers started addressing complex problems in NLP by developing hard-coded rules. And it was eventually developed into grammar parsers or language parsers or grammatical models. And then in 1990, statistical models were popular, which led to machine learning. So machine learning algorithms were then more popular towards handling or solving NLP tasks. And in 2000, so the first neural language model, which was only a single feed-forward neural uh, layer, uh, was introduced, and then it was soon replaced with RNNs and LSTM. And then in 2010, although the deep learning was started with the rise of neural language models or neural networks, the deep learning became somewhat common or somewhat popular in early 2010. So then the progression was to make use of RNNs or LSTMs in order to process the language. So since then, so neural models have overtaken the conventional machine learning algorithms in terms of language processing. So the early recurrent neural networks were actually supporting uh, processing of text or sequence data. So sequence data can be text, audio inputs, or time series data, anything. So the difference between RNN and a typical feed-forward neural network is that the feed-forward neural network, although with backpropagation, it trained itself, but it never took the preceding word or the preceding example to generate the output. But in RNN, why it is different is at each time step, while it trains itself, it also considers the previous hidden state in order to produce the output. So as a result, RNNs were much more popular. But it soon came across two problems: vanishing gradient and exploding gradient problems. I will not go into detail, but these were, when it comes to processing longer sequences like conversations, keeping the context of the conversation, or when it comes to question answering, keeping the context of the document, were actually affecting because of this vanishing gradient problem. So overcoming that, two RNN units, long short-term memory LSTM and GRU units were introduced. So out of these two, LSTM, the advantage with LSTM and GRU were at the network can decide when to forget and when to actually retain the information. So it's basically operating in terms of gates, and the main advantage of GRUs over LSTMs is that the training was much more efficient. But handling longer sequences, the LSTMs supported better. And then handling sequence to sequence data. So sequence to sequence is when input is also a sequence and output is also a sequence. So for example, it's like machine translation. So input is a sentence of dynamic length, and the output is another sequence of a different length. So a single RNN encoder RNN could not handle this type of model translation models. So therefore, they had to develop encoder-decoder architecture. So encoder handles the input part and decoder handles the output or the generative part of the model. So in the early encoder-decoder architectures encoders could be RNNs, LSTMs or GRU units, and similarly decoder could also be the same. So the technique wise, so the encoder was supposed to capture the hidden state and group it into a context vector at the end of the encoder. And then the decoder was relying on this context vector, which was produced by the encoder to generate the output. So this context vector was a bottleneck, and this context vector could get its weights by considering equal weights, or can be a weighted average of the hidden states as well. And then this attention concept was introduced by Fernando. So in his architecture, uh, so when the decoder was producing a element, a decoder was producing a token, not only it relied on the context vector and the previous hidden state, but also it considered the attention of the input sequence as well. So now supposing if x1, x2, x3 and xt was the input sequence, so the attention, the additive or the multiplicative attention calculation or the attention matrix was used on top of the previously generated hidden state of the decoder to predict the next item. So, and then finally, we have transformers architecture, which is the most powerful tool or the most powerful architecture to model the sequence to sequence models, and mainly because it can greatly overcome the long-term dependency issue. This limitation is overcome because rather than taking one time step at a time in the input, it gets the entire sequence and conducts the processing. And then it because of the parallelism, it also calculates the attention matrices or the attentions in a much more much more much more accurate manner. So this is the type of model that now we use to model our NLP application. So since you have been listening to the presentation, so I thought of giving you a quiz because we have some more slides to move on. So at this point, I will put this link in the chat. So you're supposed to give an answer. So the answer is, so I'm expecting that you have some background knowledge on transformers and the sequence to sequence models. So the question is, how is the sequence order handled in transformer architecture? So let's see our responses and let's try to discuss this some more. So you can simply click on the link and give your answer. Okay, so we
Over.
have received around
Okay.
24. I think, yeah, I'll wait for like another 10 seconds, perhaps.
Alabu, just answer.
Hello?
Somebody asked one question: the transport does not process the data in sequence.
Yeah, I'll explain that. Okay, so let me discuss the question now. How is the sequence order handled in transform architecture? So the question is, because we are dealing with text, and text means the sequence matters to understand the next word, or else to understand the context, or else to understand the most the attention, the tokens which has the most attention. So because of that, the sequence order matters when it comes to NLP applications, because transformers is a CNN type of a network, and it is not directly supported to handle sequence data. But in text, this sequence or this order matters. So therefore, how do we actually feed in the order information into the transform? So as 22 people have correctly guessed, 56% have guessed, it is based on the positional encoding. So the position, so when we talk about position, so in this particular sequence, how is the sequence order handled? So how is the first position is becomes the second position, the becomes the third position, and sequence depending on the subword might have the fourth and fifth positions. So likewise, so when the attention is calculated, it should know what is the word that gives the most prominent attention. Otherwise, it will just become a bag of words and just process it. Because at the generation side, it is important to maintain the fluency of the language, because the generative models are actually language models. So therefore, even in the encoder side and even in the decoder side, this position or the sequence or the matters. So that is actually fed in using the positional encode. So the self-attention is also calculated while producing the contextual embeddings, and then the subword encodings or the token encodings are important, because that will also result in producing the contextual embedding. So all three uh, uh, undergoes all these layers of processing before it produces the final output of the transform. Okay. Are there any other questions? Is it clear for the person who has asked the question? Okay, let's move on.
Okay.
Sorry. So next we will talk about NLU versus NLG, or what is this NLU and NLG? So we talk about natural language understanding and natural language generative models, because certain, not all NLP applications need to generate text, and not so therefore, based on the ability of the model, we classify them, or we categorize them, these NLP applications into two main areas. So natural language understanding is when the models need to understand the text much more, should have the understanding of the text in order to perform the task. For example, token classification. Token classification is when it reads a sequence and label each word, whether according to the post group, or it can be named entity recognition. Based on the named entity, based on the named entity type, it can group it. So likewise, for each token, the NLP model should predict a classification or a prediction class. The other type of NLU task is at the sentence level. So sentiment analysis is one such task, or any other classification task, such as uh, spam detection, or it can be aspect-based sentiment analysis. Anything can fall under NLU task. And then information extraction. So here, or relation extraction. So these type of applications also fall under NLU, because once it sees a sequence, it should know what is the relation in that in that particular sequence, and what are the entities that it is linking the relation, defining the relation. Or else it can be semantics textual similarity. So this can be monolingual or cross-lingual. So there, the task is to identify whether the two sentences are semantically similar, or are, in the meaning wise, whether they are similar. And then paraphrasing detection. So given two sentences, it will detect whether the two sentences are basically conveying the same thing. And then question answering. So here also question answering has also a NLU part. Especially factoid type of question answering is when the model needs to give in a one word or a two-word answer. So there the NLU is more prominent. And we have another type of NLP models which focuses on the generative side. So in generative type of language modeling, we basically look at, they are basically language models. So the purpose of a language model is to output a sequence fluent in its target language, but conditioned by the given input. For example, again, question answering. So if we ask a question answering system as to why this happened, it should clearly give a answer. So that might be generated by the language model based on other factors. And then machine translation again comes as a energy task. So here also the input will be given in one language, and the decoder should generate the sentence, but it should be the translation of the input sequence. And then when it comes to text summarization, abstractive summarization is a pure example of an NLG application. Then image caption generation, conversational agents, and content creation, whether it's report generation or narrating stories or writing essays, can be anything. All these things will be coming under NLG applications. And then text simplification. So it is important to understand what type of a NLP task you are dealing with, NLU or NLG, to decide the suitable neural network architecture for it. So mainly, if it is NLU type of applications, we mostly rely on encoder-based models. If it is NLG, it can be encoder-decoder or pure decoder-based models even. So ChatGPT or these language models are mainly coming, mainly using the decoder side. But for machine translation or for question answering, there are examples for using encoder and decoder both. Okay, so get to know about the background. So now, so we are going to create a word cloud. So here, if you can give what is the NLG or NLU task that you are most familiar with or you're interested to work with, then we can have a better understanding about the background of the audience. So again, I have put the link in the chat. You may type in the interested area. Okay, so if I just explain, if I just get the slide, these are the energy tasks or NLU tasks. You can take a look at this even. Okay, so now we have received, we are receiving responses, so that's good. Okay, so it looks like most of you are working and interested onto machine translation, text summarization. Machine translation is also the area that I'm working on, which is very rewarding to see. Okay, named entity recognition, question answering, conversational agents. Okay, ChatGPT, Bard AI, machine transliteration, text simplification. Has anyone worked with Gemini or Llama, those language models? Okay, right. So interesting. So now let's continue. Right. So now we talked about neural network architectures, and then we talked about the applications. So now, how do we actually work with this text data? Because neural networks is all about numerical data. So because it's basically functions, linear functions propagating the values into the forward layers. So that's why we need to work on language representation. So how do we represent the language in terms of numbers? So now we have we call them as embedding. So the early type of language representations were basically statisticals, which basically considered bag of words, TF-IDF, or the context was only captured in terms of n-gram bag of words or n-gram TF-IDF models. But it was not actually processing any semantics, but it was only limiting to uh, representing the sequence or the words in terms of its n-grams. So that was not very powerful enough. So because afterwards, the language representation moved into. Hello, any question? You may put in the chat.
I think yes, I think somebody on mute. Anyway, I'll
Okay,
put
right.
everyone.
Yeah, I'll continue. So the context-dependent type of word embedding models were basically early word embedding models were word-to-vec, glove, fast text, but they had their limitations. Uh, so they were context independent. For example, if there was a word, the word always had a single representation, but we all know a word can have multiple senses. For example, if it's the word bank, bank can be the bank organization, the financial institute, or else it can be the river bank. So if we are representing one word in all both contexts with a single representation, then naturally it will not be successful. So these word-to-word club fast text models were that. So then when it comes to representing the sentences and document level representations, then the accuracy degraded uh, drastically. So afterwards, what is now what we use is this context dependent embedding. So context-dependent embeddings has been produced by RNN networks or nowadays using the transformer-based architectures. So the Elmo and Co were basically RNN-produced context-dependent embeddings, but the problem with Elmo was that it was unidirectional. Especially now we know in a sequence, a particular word might have a relation with some other words towards the right or towards the left. I mean, the left is basically the context, but right side word ordering can also be important to actually understand the meaning. For example, certain sentences can negate towards the end, especially uh, text which contains sarcasm. So, so then the negation can occur at the end, which sort of uh, uh, gives the opposite meaning when it is coming to the end. So therefore, bidirectional context is needed when it comes to producing contextualized embedding. So that is the strength of BERT and the subsequent models. So the BERT was bidirectional. That means it could capture both context in its representation, and it was contextualized, meaning that the embedding will actually change depending on the context, not really the position, but depending on the instance of the usage. So therefore, BERT models or the transformer-based models were much more powerful in terms of language representation. So whether it's word embeddings or sentence representation, so because BERT, XLMR, Roberta models, they mainly specialized in terms of sequence representations or sentence representations. They are much more capable of solving or giving good performances when it comes to sentence level or document level tasks. So therefore, now we can also make use of these word embedding models, or these we call as language models, pre-trained language models, to initialize our tokens in our sequence. So therefore, that is the paradigm we are basically following now. That is, we benefit by the pre-trained language models. So pre-trained models are models such as BERT, Roberta, XLMR, uh, LabSe, those models which are capable of giving a very good initialization for our NLP application. So therefore, we rely on these contextualized word embedding models to in our NLP applications. So next we will look at a text classification problem, how to solve a text classification problem. And this particular problem we are going to select as sentiment analysis. So sentiment analysis, we will see how to uh, how to implement it. So before moving on to the practical session, let's identify some strong points or the theory behind how we do this task. So as I said before, now we mainly rely on pre-trained models. So when we talk about birth models were actually, the birth model was purely a English model. And now the pre-trained models are more or less multilingual models, meaning that it has several languages. So in case of birth, XLMR and XLMR Roberta or XLM, they basically capture around 100 or more sentences. So these pre-trained models can be multilingual, cross-lingual, or monolingual. So what do we mean by multilingual? Multilingual is we have a single pre-trained model uh, considering hundreds or several hundreds of languages. Cross-lingual is when the model has been trained for two or three several languages. And then monolingual models such as Chinese birth, English birth. So these models basically are monolingual. That is, it is good at only giving representation for that particular language only. And the other benefit of using pre-trained models are that already these models have been trained on massive large-scale data sets. And as a result, they have learned the linguistic features specific to a language, if the particular language is covered in the data set, or from the language family, or from the related language families. Likewise, the linguistic features have already been learned by these models. So then what we have to do is to train these models to this specific task. So then we call this as fine tuning. So provided that we have a pre-trained model, and then we have a specific task we want to get this model to work on, we find a small, uh, we find a reasonable size data set and we do a fine tune. So in case of a classification task, on top of the pre-trained model, we add a classification layer, a final layer, and we train the entire pre-trained model weights plus the final layer weights in order to produce a proper prediction probability. So for example, in this particular diagram, now you see that the application is a classification task, but this is supposed to classify whether the news is fake or real. Now this is actually needed in real world situation. Uh, to detect whether it is whether the news is legit or not. So, and then this fine-tuning task also eliminates the need for large-scale data sets and computation power. Mostly, this fine-tuning task requires TPUs. So it's very time consuming for us to train everything from scratch, especially when it comes to low resource languages or developing countries. We have we don't have much computation power or the hardware or the data sets in a large scale. So therefore, this is very advantageous for us to rely on these pre-trained models to boost the performance of our in-task accuracy. So now let's try to do this together. So I have chosen a sentiment analysis task. So as the data set, I'm going to use the Twitter airline sentiment data set. So it is available publicly in Kaggle. So I'll put that link there. And then we need an environment to train or to train and to work with our data. So I'm choosing this collab environment, uh, which is uh, which is very useful. And I have actually a notebook available which I can share, and this downloaded dataset is also available in a shared drive. So I'll share this collab notebook, but don't try to execute it here itself. You can take a copy and in your own Google Drive or your Google environment, you can use this. You can take a copy and use this notebook. So when we work with the collab environment, what I would suggest is to first install the environment. So I'll give some time until everyone has access to the notebook. You can take your own copy. Save a copy in the drive. So if I explain this data set, now this data set is actually taken from Twitter using the Twitter API. The airline sentiment data set has been, this tweets have been taken about the airline. So they have much more data. For example, so there is the tweet ID, the airline sentiment. So usually sentiment can be positive, negative, or neutral. uh, or else they have also given a score for the sentiment, and then there are some more additional data as well. So it has data of several airlines. So US Airways, American Airlines, Delta Airlines. So the airline data is also there. Then name means the person's name. So likewise, the data is available but only thing is we will only need several columns of data. For example, we will consider the sentiment of the airline as positive, negative, or neutral, and then the review the person has given about the airline. So this is how the data set looks like. So here, what we are interested in the review only, and the sentiment of the airline. All the other data we can discard, and we can only focus on these two. So likewise, we have to first observe the data set and identify the actual data that we need. And then we need to decide whether we need to apply any other cleaning steps. So cleaning steps is when particular data can be missing, uh, or else it might be that the text has junk. So it can depend whatever the reason. You may consider. You may look at the data and decide what is the particular data, whether you are good enough to take the entire data set, or only or whether you need to filter. And in some of the NLP text, when you observe, you might see that the data, some reviews or some textual data is limited to one or two words only. So we really don't need that type of data. So we can define a max length and a min length, and then take the relevant data that is suitable for us. Or else if there's lot of noise, for example, if it has like uh, URLs embedded or just using regular expression, what is the proportion, what is the percentage of the text, and then based on the ratio you can to conduct your task. So that is somewhere below the line, but here initially we will try to set up the environment. So I'm going to implement this using on top of the Transformers library, which is a very popular library which supports the pre-processing like tokenizing, and then it also has pre-trained models where we can directly use them using a single API. So Transformers library is very flexible in that sense. So I'm using Transformers library, but if someone else needs directly implement this on PyTorch or TensorFlow, or else there's another library called Sentence Transformers, Simple Transformers. There can be much more available libraries for you to implement this fine-tuning task. And this accelerate is a dependency And then I have also installed datasets, evaluates, matplotlib, seaborn, and weights and biases. So if I explain what is dataset, so again, Hugging Face has a standard way of saving and representing the input data. So I want to make use of that dataset structure to pass my inputs into the training model. So as a result, I will make use of this dataset library as well. Then evaluate again comes with the models where we want to evaluate the final, finally the model performance we want to evaluate. So this evaluate can be used to finally evaluate as well as implement a loss function at the time of training event. So using the validations dataset, we can write a function to calculate the loss based on our dataset. Matplotlib and Seaborn are basically for visualization, so it can be during training or it can be after training as well. So there's another additional library called weights and biases. This is actually useful when it comes to training multiple models. When you're conducting several experiments, you want to compare between experiments. A single experiment performance in terms of loss or accuracy can be visualized using a tensor board, but this weights and biases API supports you to visualize the accuracy graphs, the loss graphs across different experiments. So I will just show you the uh, interface. So this is weights and biases. You can use this website and you can register it. Right, so using your own login, you can create an account there, and once you create an account, now I have created an account, and you will get a API key. So making use of this API key, you can log the losses and accuracies while the training is going on. So I'll just show you an example. So these are several experiments I have conducted for another classification task. So here these are several experiments. So you can see, we can see clearly. We can visualize and see where accuracies are in terms of the different settings we have used. So in this particular to log the particular training graphs, I have created a project called Twitter US and Airline Sentiment Analysis. So once you create an account here, you can create a project, and then this project can be used in your training script to link up with the losses or the accuracies, and it will upload the script will upload the data into this website. So, but in your Colab environment, you need to install it because it doesn't come pre-installed with the other software. And then scikit-learn, you can use this to generate the confusion matrix report or for your evaluations even. And then provided that you have created an account, you can install the weights and biases library, and using the API key, you can give in the login key. Okay, right. Sorry about that. So once you have installed the library, you have to then log in using the API key given for your account. And then there are some environment variables you need to set. So since you have access to the Collab notebook, you will have access to these environment variables as well. So here we pass the project name. So that is how the script will know what is the project to link up the values with, and then whether to log it, and then whether to observe. So you can set these parameters, and when these parameters are set, while it is training, you can see the graphs being drawn. Then you can, as and when it trains, you can right. So that is basically those are the steps for you to install your environment related software and its dependencies, and to set the environment variable. So next, we want to link up the collab. Uh, we want to link up the Google Drive, because that is where you will be having your data, the Twitter data that you CSV that you downloaded. You can maintain that in your Google Drive, and then you can read the data from that drive location. And similarly, when the training happens, you can write these models to the Google Drive location as well. So therefore, you can link up the Google Drive location. And these are the import statements. So in the import statements, you can see the libraries what we are going to use. Basically, we will make use of pandas and data frames or data sets in order to handle the input data. Um, and then to generate the classification report, the confusion matrix values, and the final accuracy scores, we will be using scikit-learn. And then we will use PyTorch to uh, access some of its functions, such as to uh, reshape the target uh, label values, etc. And then we will come across these libraries while we execute the rest of the document. So now a key advantage for you will be to uh, learn about and have an understanding on the data. As I said before, to see whether the data is clean, or in what way it needs to be cleaned, or what way it needs to be filtered. So therefore, it's important for you to get a glimpse of what your data set is. So as I said before, although the dataset comes with several other values, I have limited to only getting the review data and the reference label. So reference label is the sentiment is given as neutral, positive, and negative. But uh, as I said before, we need all these data to be represented in numerical form, because the purpose of this data is to be fed to the neural network for the classification task. So if I explain this further, so you can make use of the, what I have done here is I have read because this input data is in a CSV file, using a CSV reader, I have read the review information as well as the label information into the data set. And I have saved them as lists, and then I have created a data frame object by passing this as a dictionary. So the dictionary keys are reviews. The reviews list, I have maintained it as the reviews key, and the labels list I have maintained it under the reference labels key. So this is passed as a data frame object mainly because manipulating the data is very much easy when it comes to data frames. So first and foremost, let's look at the distribution of the classes. Now in this particular data set, it has negative class 9,000 records, neutral class 3,000 records, positive class 2,363 records. So as you can see, this is not a balanced data set. So negative 9,000 and the other two are not coming close even. So you can take a decision whether to limit all the classes to 2,363, but then that would mean your data set size will be drastically reduced. So you can take decisions like that and decide finally what is the data set size you are going ahead with. And here, when it comes to the labels, now reference labels, also we need to convert this into numerical form. So I'm going to label the negatives as 0, positives as 1, neutral as 2. So then when I preview the first 10 records in the data frame, I can now see that the labels are now numerical. Still, this text uh, is not numerical because we have not done any processing for the input review. And then, as I said before, you can see whether there are duplicates, because duplicate removal is essential, because we cannot have any training overlapping examples in the training set and in the evaluation set. So therefore, deduplication is important, and it is very much directly supported if you are using data frames. Yeah. And now, after deduplicating, we have a data set size of 14,640. And now here in the next code segment, what I have done is I have tried to create training, validation, and testing data splits. Now, if I just take randomly, split this 14,000 randomly into 80% training, 10% testing, and 10% as validation set, then again, I'm not sure in these data splits what is the biasness for each of the prediction classes. So therefore, what I have done is I have taken all the positives, and from all the positives, I have distributed 80% into training, 10% into testing, and another 10% into validation. So here, now I have considered a subset from the original data frame as DEF positives, and in that subset, from that subset, I have sampled examples for the training, validation, and testing. Again, For the negative and neutral classes also, I have done the same. And finally, I have concatenated these data frames so that I will have the final training data frame containing the training examples, validation data frame containing the validation examples for tuning, and data frame for testing containing the examples for evaluation. And the next thing is shuffling. Again, that is done to randomize and to reduce the biasness of the training data set or all the data splits. So this is the function. The sampling function can be used, which is given by the data frame, to shuffle the data. And then now I have dropped the reference label column. So reference label column means the words which contain in the sentiment as neutral, positive and negative, because I don't want that in my processing. Now I want to limit this into processing into labels, and reviews also, it's not ready yet. So now next we are going to um, focus on uh, pre-processing the textual input. So once you have finalized the data splits, you can use the group by function, and you can see what is the distribution of each of these prediction classes in each of the data splits. And here I have created a dataset dictionary. So here the purpose is to convert this information because I'm using the Hugging Face Transformers library. So dataset, if I if I structure all my input data into the dataset object, then I can easily use the API to pass the values. And now I said when we are building up the application, we want to do it as a fine tuning of a pre-trained model. So as the pre-trained model, I have used XLMR Roberta base model. So base model is basically the number of layers. So base model has 12 layers. If it is XLM Roberta large, it has 24 layers. Likewise, or if it is a medium, it will have lesser number of layers. So even for BERT models, there are different variants of these pre-trained models. So the nice thing about using Hugging Face API is that using the general, you don't have to change the code depending on each pre-trained model. You can maintain your own code, and then you can change the pre-trained model parameter, and then the rest will happen smoothly. So I have initialized the tokenizer and a model for training. So the objective of the tokenizer is to pre-process the data. So I mentioned that we want to work with reviews. So reviews is the textual part of the input data. And then so the reviews, each example, we tokenize it, and after tokenizing, what happens is that each of the words, this input sequence will be broken down into subwords, and uh, it will generate a uh, uh, input ID vector for each sequence. So this input IDs is actually referred from the here we have used the pre-trained model as XMLR. So XLMR model contains a dictionary, input dictionary. So this dictionary contains unique IDs for all the vocabulary. So number one will be one character, number two will be a subword, number three will be a word. So looking as a dictionary lookup, it will generate this input ID vector. And then attention mask is again another vector that is written based on the pre-processing that will indicate what are the tokens for which the attention should be calculated, because we conduct something called a padding, because not all the sequences are of equal length, but each batch we take it into an equal length size matrix, so or tensor. So in order to have the fixed size width for the particular batch, we pad it with zeros. If the sequence is longer, we truncate it. We cut the sequence and get only the sequence part which is subjected to this maximum length. If the sequence length is less than the maximum length, then the padding will happen. It will append zeros to the rest of the sequence. So that is the pre-processing part. Then we pass some training arguments. So training arguments basically will have the learning rate and then the save strategy. So this can be saved and calculated, evaluated in terms of steps or epochs. So if it is steps, we can specify the number of steps. If it is epochs, we can specify the number of epochs. And this is the maximum number of epochs we conduct this training. And then we can do this. Then we can initialize the trainer object, and then we can call the trainer to conduct the training. So I have defined a compute matrix as well. So here what happens is, now we specify this evaluation strategy and the number of steps. So during training, when this number of steps reaches 88, it will call this function and do a evaluation and calculate the losses and accuracy. So here I am also asking to predict the accuracy as well. So once this is called, uh, here the step count is shown here. After 88 steps, always the training loss, validation loss, and the accuracy is calculated. And then the best model is saved. So we can configure that. So we can say best model to say looking at the loss or the accuracy. We can define it according to the training algorithm. And then we can do the evaluation. So actually for my training work, I'm actually using a GPU. So in this command line, I execute the training. So this is how the training values will look like. Um, this is actually the training loss, and this is the evaluation loss on the validation set. And finally, I can print the training arguments. So not only the arguments I have specified, but also the default arguments are put out. So you can actually go through these arguments and see whether you want a particular value to be changed. And then it prints out the confusion matrix. So since there is a multi-class classification, so against each and every prediction class, it gives the accuracy. And then finally, it will upload all the configurations, the values, the calculation values into weights and biases. And then from here, you can actually view the graph. So that is basically how you conduct a sentiment classification, not only sentiment, but also any classification task. So here in this case, I have gone for a multi-class classification in terms of 2 classes. So, but depending on your application, you might have more than 3 classes. So another visualization what you can get is this heat map. So you can visualize depending on the the uh, density of this color, how dark the color is, it will show the higher values in darker colors and the lesser values in lighter colors. So here now you can see that diagonal wise the values are higher. So that means it has managed, the classification model has actually managed to predict these classes with some accuracy. If you look at what the accuracy is, here you can see the F1 score for each of the classes: 91%, 79%, 63%. So the 63% can be because of the dataset imbalance, or else if you are talking about the overall accuracy for the entire classification model, then it is 78%. So that can be reported as the final model performance. So basically that is the application I wanted to um, discuss. So finally, once you are done with the training, you can even upload your model, fine-tune model. Let's say you are doing this specific to Hindi or any native dialect or any language. So that model can be uploaded into the Hugging Face models repository so that it can be publicly shared with anyone. So these will be some useful visualization tools, and then you can practice this. You can get a copy of this notebook and you can practice this as well. So I think we have almost reached the time limit, but I can answer one or two questions if it's okay with Dr. Samter.
You can take another 5 minutes also. No problem.
Okay, sure. So if there are questions, you can leave it in the chat.
Yes. Ankisa, can you see the questions in chat box that you can ask to ma'am? Just check once.
Yeah, I have the chat box.
I think ma'am, no questions are there like that.
Yes, I think as a challenge, I would suggest now here I have used XMLR, which is an encoder model to initialize and do the fine tuning, but you can take up any decoder model as well, such as ChatGPT or any other decoder model as well also, and try the same experiment. Or else if you're focusing on sequence to sequence model, you can take the encoder part of the sequence to sequence model, such as MBAT or MT5, those models, and take the encoder part of it and even try to get the embeddings and see what actually works better. So for that kind of a comparison, the weights and biases will be ideal too. I have shared the link for the collab file, so it can be, I have given access to anyone with the link to copy it or to download it. So I will again put that in the chat. Right. So that's the. It's okay.
Aloka ma'am, we can stop here. We'll or
Okay. Sure. Right. Okay. Then. Thank you very much for your time. Have a nice day.
uh, as you know, ma'am has covered a lot and given from scratch about the NLU, NLP. So again, I am asking the same thing. If anyone interested to do any kind of work in this particular domain, definitely can contact me or to ma'am directly. And after the workshop, definitely we are going to formulate some problems and we'll contact to Aloka ma'am so that we can try to execute those things. Okay, and you just feel the feedback from. Thank you, Aloka ma'am. In this Christmas week, you have given your
Okay.
time
My
to us,
pleasure.
and definitely our collaboration will be there to do some more work and training program also. Thank you, ma'am. Thank you. Bye.
Okay.
Have
Thank
a
you,
good
Dr.
day. Bye.
Satya.
Bye. Thank you.
Have a good day.